to why the answer is what it is. And remember, you might have tried problems that you are not ready yet to see. So it's totally okay to be asking me questions. It's what I prefer, it's what I hope will happen now. Anything that you want to ask about? Let's start on the non-calculator section, which I think is numbers 1 through 45? No, 28. 28, sorry. Sean, what do you got?
Could you please verbalize number 8?
Number 8, yeah. Keep shouting out, guys. I'm just going to go take a picture of number 8 so that we have it. I kind of have a separate file where I'm going to be putting these.
Next, number 21.
17.
I heard 17. I heard 21. I'm going to go get them. We can keep going.
22. 24.
I heard 22 and 24. Give me just a second. You can keep looking. Let me get caught up just a little bit.
25.
Give me just a second. I think in order there was 21, then 22.
Get a staple remover.
Yes. Somewhere. If you give me a sec, I'll go find it. It's not out, sadly.
Well, I mean, that's smart.
It might be a little bit of a dangerous tool. I had 22, then I think I heard next 24 and 25.
Yeah, and 26.
Then 20.
And 27. 28. Yeah.
In fact, just the entire package.
Okay, pause. Pause. Number 27 you cannot do, so go ahead and put an X through that. You can do average rate if you want to highlight. You cannot yet do average value. So if you did try 27, it's okay. Just put a little line for yourselves to realize that is not yet something that we can do. We need integration for that, so good question. Let me look here. 26. Hold on, wait. I said area. I said area is a no unless you use your calculator, which this is not. So area is a no. So 24 is a yes. We can do 24. I should have been looking. 25 is a not yet. 26 is a yes. 27 is a not yet. Okay? So it's good that you got stuck on 25 and on 27. There might be some other not yets, but those are the ones that I've caught so far.
I don't have that page.
All right, anything else on non-calculator? We went over, if you missed it, Sarah, I think, not went over. They're asking for questions on 8 and 17, 21, 22, 24, and 26.
And 28.
28, we don't like trig?
No, I got the answer.
Don't like chain rule?
It's 4. Did I get it right? I don't know. I haven't checked the answer.
That doesn't sound good. I'm not sure you should have confessed that.
A 28. Well, I mean, I don't know.
All right, now non-calculator section. Any questions on non-calculator section? That's the 70s and beyond. If you guys are curious why they skip numbers, it's basically just to let you guys reevaluate. In case you've gotten off, you can get back on, that sort of thing. So they skip it on the actual AP as well. So anything 76 and beyond? 79? Okay, hold on. 77. Let me go back and get that one. Parallel tangent lines. Hey, parallel means same slope. Same slope. Grab out your graphing calculator. I'm going to go and get mine opening up because we are going to need to access a couple things in it. 77, 79. Okay, sorry, now I'm ready.
80.
Okay, critical values, very similar to critical numbers. Just going over vocab while we're looking at it. I heard 86. Anything before 86? 83 and 84. Let me get there. Maybe, maybe not. We already found a couple that people thought they could do that they couldn't. Let me go get 86 really quick.
The answer is no.
Ooh, 86 is definitely a not yet. That's the last thing we're going to learn this year. 86 is a not yet.
76.
Uh-oh, we're going way back.
Wait, what? Everybody says it.
No, we didn't.
Don't get arrested.
What made you think I was going to get arrested?
I just feel like
Okay. Thanks, Sarah. That makes sense. Thanks for your valuable input.
I heard Sarah having a question somewhere in the 90s. I think we left off around 84. Anything in between 84 and the 90s? A lot of them actually we can't do yet. Well, there's a couple we could do. We could do 87. Okay, what was the question? You had a question on, Sarah? 92?
Oh, yeah.
92 is a no, not yet. The area, yeah, area under the curve, that's integration, so not yet. You said 91, right?
Yes.
Okay, that one's possible right now. Did you guys see that related rates one in number 90?
Yeah, yep. Still got it wrong.
Do you have a question on 90, or are we okay?
The explanation made sense.
Okay. Other one?
Is it D?
What, number 90? Didn't you already grade the quiz one?
I think it is, but I think it is.
1/2 base times height.
It could be or C.
I mean, we can do it as a 90 real quick.
I know it's 1/2 base times height. 1/2 times 1/2 times height times 3.
Why are we taking a derivative at all?
Because we want to have rates.
Rate. Good. So then we could say, what, dA dt? Question, what rule are we going to have to use over here? Product, it's a times, right? Read it to yourselves. Base times height. Product rule. So second d first plus first d second. They did give us a few things, right? They said the base is increasing. What kind of number do we do with an increasing rate? Positive or negative? So we're going to say 1/2 positive 3 inches per minute times height plus height is decreasing, so negative, right? Negative 3 times base. Plugging in for dH dt, rate of height, and dB dt, rate of base. So they're asking what's going on with the area. But if you look, it all says increasing, decreasing, remains constant. That's talking about the rate of area. So first of all, in order to be increasing, wouldn't dA dt have to be always positive, regardless of B's and H's? The question, will this always be positive? What if H is 1 and B is 2? That's a negative number. Well, I know it's not always increasing. Since B's and H's can change, the triangle is going to be changing size. This is going to be different numbers. It can't be remaining constant. That would be one number alone. Like if dA dt was 2. But it's not. It's going to be changing. Is A going to be always decreasing?
No.
No. What if H was 2 and B was 1? It would be a positive. It would be increasing. All right, so now we need to think about which is which. If B is less than H, just pick an example. That's really abstract. B is less than H. Okay, so B could be 1, H could be 2. So if B was 1, negative 3. H was 2, positive 6. That's a positive number, right? Positive? Nope. Now B is greater than H, okay? So B is 2 and H is 1. I'm just picking an example. B could be 3, H could be 1/2, B could be 10, H could be 5. I just made up one. So 2 and 1. 2, negative 6, 1, positive 3, a negative number. Dun, 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 dun. A little weird. But related rates start with area of a triangle formula. They didn't give you that. That's one we need to have memorized. Take the derivative with product rule. And then consider the different cases when you use different B's and H's. All right. I didn't really hear anything else. Oh, 92 is the last one. That's why. So let's go ahead and go peek at the questions you have. I think we pulled out a lot of the ones you could try. Probably only skipped a couple of the ones that you couldn't try. This is recorded. This is recorded. If you want to go back over it a little bit longer, you may. The big reason I need you guys to have it attempted and graded and looking at the solutions in the back of the packet was so that you would know what to ask me right now. So I'm gonna go through these pretty quickly. If you want to pull out a different colored pen, if you have one, you could show a difference between what you were able to get versus what you weren't able to get. That's one idea. Or you could just do the same color as you were grading and maybe put a little star by it, like, oh, this is what I wasn't able to get before. I might not do these in full detail. And to be honest, how many of you guys, even after, if I were to give like short, sweet versions, how many of you guys want tonight to look at this a little bit more? Okay, so we'll go ahead and collect it tomorrow. Does that sound good? But we needed it attempted for right now, so we need to look at questions you have. Number 8, Sean, you're asking for a verbalization of what was going on.
Yeah.
We know F and G are differentiable, which also technically means, since they're differentiable, that's a forever card. We also know they have to be continuous as well. We know G is greater than 0, so G is going to be above the x-axis, I suppose. Has positive y values, and we know f of 0 equals 1. Well, that's not a lot of information. So we know 1 point on f, and we know that G is positive everywhere. Okay, they give us h is equal to f times g, and h, wait, h prime, how would we ignore? You gotta ignore what they're giving you. You know how to take the derivative of a product. How do we take a derivative of a product, guys? So what's the proper way? What way would you have had to derive that? Second? D first. Plus?
First.
Good. What's missing from what they said?
Well, they got rid of the
This disappeared.
Yeah.
implies
What's
that
the
F
only
prime
way this
is
could
0.
disappear? If G is always a positive number, F prime must have been, see it?
Which means it was a constant.
Which means it was a constant. It meaning F was a constant. Look at the clue they gave you. If they told you what F was at one point, and we know that F is constant, what is F at? F is
1. Yeah,
Now, what made that one hard? You guys got stuck on what they told you and didn't think about what you could do on your own. Anytime you see a derivative, there is a proper rule that had to be used. The only way this was possible was if f prime was 0, so we knew a lot more than maybe you think you did. Number 17 is the graph of who? Super important.
Function, the function.
Twice differentiable means you can take a second derivative, but the graph is of adjective, who?
The
F.
function.
I know that. Gotta be careful that English gets a little bit confusing. Twice differentiable is an adjective of f. This is the graph of f of x. So question. F is going to be the y values. How are we going to see f prime? Yeah, look at the slopes of the tangent lines, right? So we can look at the slopes, and how are the slopes indicated? You can look also at the increasing, decreasing of f, right?
Positive.
Since the function is always increasing, f prime must be always positive. Since the function is always increasing, f prime is always positive. F is going to be, well, negative down here and positive up there because it's below and above. So we'll just say for this one, y values, we'll say above and below. How about f double prime? How do we see that of f? Concavity test, right? So f double prime is going to be concavity. Now hold on, what concavity does this have?
Down.
So therefore,
Sound like a
Would
problem.
be a negative.
that's going to be negative. Now pause. Just knowing those facts, what answer choices can you eliminate?
I think
Why am I
maybe
crossing?
you're going in A.
Hold on, this is looking at 1, right? Hold on, pause. What is f, the y value at 1? That's the one thing that we didn't plug in.
0.
0. Because it's an intercept. So the y, no, I thought it too. So the y value at 1 is 0. The slope is positive. The concavity is down. Okay. So guys, what order would you put it in before even looking at the answer choices?
Negative 0.
F double prime?
Prime.
F prime. Which one has F double prime? F and then F prime. Dun, 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 dun. will be on the video. I'll probably do 2 different videos for today, one for period 1, one for period 6, because your questions might be different, although I bet they're pretty the same. Pretty the same? Pretty similar. I know, awkward. Number 21, if dy dt, ooh, okay, well, this is kind of integration.
Kind of.
Meaning, yeah. Why am I gonna cross that out and say you can't do it yet? They gave you what? A derivative, and they're asking you to go backwards. That's integration.
Yeah, I figured this.
That's our new stuff. That's an anti-derivative. Not ready yet. Not ready yet. Number 22. What's the key word? Yeah, they give us a function. Good stuff. Not a graph, not a table. A function. Good old function. What are they asking for?
Increasing.
Ooh.
Oh, a sign chart. Wait.
Increasing.
Yeah.
An interval and increasing. That did not work. Increasing. I'm looking at a sign chart of who? F prime. Increasing test. F prime. Wait a minute. How do I get a sign chart of F prime?
The right. Go at it.
I need to take the derivative.
Okay.
I need to find the critical numbers. I need to test my intervals. So, kiddos, you did this. What was your derivative? Did you do some factoring to make it look a little nicer? Plus 1?
Yeah.
Set equal to?
0.
No DNEs, no pitchfork, because there's no denominator. Set the first one equal to 0. Don't I get x equals 0? Second one equal to 0. I get plus or minus square root of a -1/2, which is imaginary. No imaginary numbers on my real number line. Don't belong. So therefore, that one doesn't have any zeros. This one did, and I have them. That was my critical number. I tested a little bit before and a little bit after. Wait! Look! Can't I say I have a 50% chance of getting it right?
Well, yeah, but
Go
it doesn't
team.
take much more work to.
It doesn't. We're going to get 100% right, but I'm just saying. Just saying. Okay, if I plug in, where am I going? A -1? That's a negative. This is always positive. But a negative times a positive is a decreasing. Well, not that interval. And then this one, if I plug in a positive one, positive times a positive is a increasing. What interval is this? See, we got it right. Hey, do you guys see how the Forever Card vocab shows up? And how we have to look at the vocab, go attach it to an idea, and know how to proceed? Ooh, this just got small. Hold on, let me make these a little bit bigger. Okay,
What are we on now?
24.
24.
Oh, now I have to find it in this stack of papers.
Yeah.
Oh,
Maximum acceleration, don't forget. Max. We can use a first derivative test, or second derivative test, or just test the critical numbers and endpoints if it's a closed interval.
It is. Or you could just.
Closed interval. Can I just test the critical numbers and endpoints? All the t's, but what if they had some fractionally ones?
Actually,
We're hoping it's a non-calculator, so no decimally ones. But anyway, hold on. Acceleration. I don't even have acceleration, do I? Take the derivative. Acceleration is the rate of change of velocity. How quickly your accelerator, your velocity is changing. And you take the derivative. So hopefully you guys got 3t squared minus 6t plus 12 as our acceleration. But question, why am I doing a prime?
yeah, because it's acceleration.
Max, I need the first derivative of whoever I'm looking at. So I needed a prime. Not only did you have to take a derivative to find acceleration, you have to take a derivative again to find the max of acceleration. Because we need to find his critical numbers. His critical numbers, you gotta look at A prime, which is V double prime, which is S triple prime, called jerk. But long story short, I need max acceleration. His critical numbers, 6t minus 6 equals 0 at, what's my critical number? 1. My critical number is t equals 1. Hold on, first of all, they were really nice and didn't put 1 as an answer choice. I would have totally put 1 as an answer choice. Obviously, 1 is not what they were asking for. What are they asking for?
Asking for
All of this is just description. They want the maximum acceleration. What is t? Time. I don't want time, I want acceleration. Oh, so plug in 1 to acceleration, right? Well, hold on, have we even figured out if 1's the max
the
yet?
endpoints.
It doesn't say relative max, it says the max, so we need to test the endpoints with the critical numbers. And we need to plug into, who are we trying to find the max of? Acceleration, plug into him. Plugging in 0, I get 12. Is 12 an answer choice? Oh, I'm on the right line, whatever I'm trying to say. It's Monday. I'm on the right track now. Plugging in 1. 3 minus 6 is negative 3 plus 12 is 9. That's not going to be a max. Plugging in 3, I get 3 squared is 9, 9 and 3 is 27. 27 minus 18 is going to be 9. 9 plus 12 is 21. Now pause. Am I going to judge if that took you 3 minutes to figure out that it was 21? No. Because you're going to get it right, it's just going to take you a little bit longer. Don't do mental math and mess it up. And don't get overwhelmed that I go a little fast sometimes, because you guys know I make mistakes, yeah? I never hide that. You guys agree? Letter D? Critical numbers, endpoints of acceleration. We had to take A prime.
So apparently if your acceleration is 3t minus 2, or instead of t squared, if you take out the t squared and it's just 3t, it's still 21.
Oh, weird. Yeah,
Because
because it'd be 9 plus 12.
I think you're wrong, and I still got it right.
Every now and then it works out. It's kind of like every now and then a guess gets you the points, even though you totally guessed. Well, that's why if you're ever stuck on an AP, it's a good place to come in, David. If you're ever stuck on an AP question, it's worth a guess. Because Nathan did this one wrong, and he still happened to get 21. He'd still get the points just as someone who knew it perfectly. So never not guess. Anyway, that's awkward. 26.
Don't never all guess. Wait, I think have you said that right?
No, I said it right. Because never guess, that's not what I want. Never not guess. No, that's, always guess. But I don't want you always guessing. I want you always solving if you need to guessing. Pause, 26. This is pointless. Function f, not pointless, just not very helpful. F is continuous. On the closed interval. Ooh. And has 2 values that are given in the table. The equation f of x equals 1/2 must have at least 2 solutions if, what theorem?
IVT.
IVT. Why not mean? Mean says continuous and differentiable. Well, they didn't tell me that. But also, doesn't mean and roles, don't they both say f prime must equal somebody?
Yeah.
Okay, that doesn't work. This says f equals somebody. That has to be IVT. IVT is the weird one with k's. They were nice and even put a K. Okay, they don't always do that. Huh. Okay, never mind. So, some of you are like, I don't know. Pause. Worst comes to worst. F, I can look at F. I mean, I can't know a lot. I know 2 things. I know 0, 1. And I know 1, I don't know. And I know 2, 2. And they say the y value must be 1/2. Well, guys, where's 1/2? What has to happen at 1 to make sure this dips down and back up? It has to be below it. So which one's below 1/2?
0.
IVT says the function, if it's continuous, must go from one y value to another, passing through every in-between value at least once. It's going to pass through 1/2 if it has to go below. And it's going to pass through 1/2 if it has to come back up. This one, it could have just gone down and up. It could have only hit once. This one, it didn't have to hit it all. This one and that one, same thing, didn't have to hit it all. But only if it goes through 0 will it have to pass through 2 times. Number 28, chain rule problem, my guess, because this is just a derivative. So find the derivative first. And don't you see an outside, inside? Chain rule says derivative of the outside. What's the derivative of tangent? Ooh, we have to know our rules.
Secant squared.
Secant squared. Wait. Derivative of the outside. Keep the inside. F prime of keep the u. Then multiply the u prime. Who's derivative of 2x? The only one that answers. Ooh. see why I make you study your forever cards, including the unit circle? You did a great job if you got that far, but you wouldn't make it all the way without guessing unless you knew your unit circle. Why am I making it 1 over cosine? Because it's easier to
That's
figure.
easy.
2 times pi over 6. 2 over 6 is 1 over 3 times 2. Pi over 3 is what kind of angle? 60 degrees, which is over a little, or cheater chart. It's a 3, 2, 1, 1/2. If you have struggles with the unit circle, I can get you to know it. You just have to come in and let me have a chance. Cosine is 1/2. Sine is square root of 3 over 2, but we don't want sine, we want cosine. We gotta square it. What's the square root of 1/2? What's 1 over 1/4? 4. And what's 4 times 2?
8.
That's a dun 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 dun. Wouldn't most of you have guessed a radical one just because it's unit circle nastiness?
Yeah.
You would have been wrong. Not to say they never use the radically one, just saying. Just saying. Whew, we're finally on the calculator part. We're finally on the calculator part, but no calculator was necessary in 76. Who is this the graph of? You gotta establish that first.
F.
This is F. This is F. Is F continuous at A? No! There's a break! The limit says one thing, the function says another, so heck no, technically. But wait.
Statement's false, boys.
Woo!
That'll be bad.
Woo! If we don't read the question, can we get in trouble? That is the answer because that is false.
I didn't lay this out in the correct order.
That's a little bit of a struggle, bud.
Oh, here.
I literally put it on your desk in the work.
I know, but I've
What a good brother. Look at that. Alright, 77. Can we do it?
Yes,
Parallel tangent lines mean same slope. Now hold on. Nasty decimals. Wait, slope. I'm not going to set f equal to g. I'm going to set
F prime.
f prime equal to
G prime.
g prime. G prime's easy. 18x squared. F prime is gross. But how do I take the derivative of, wait, constant multiple, e to the u?
E to the times.
You guys okay? E to the 2x times 2. Hence? Well, this is easy. Why have you my calculator? How is it? These two equal.
Yeah.
2 options. Can you use your calculator?
Yes.
2 options. No, I need to go find my thingamabob. Struggle.
6.
I have it. I just need to go find it. This is not very fun. Give me a sec. Kiddos, while I'm finding my calculator in order to be able to use it, guess what? Can't you make that y1? Can't you make that y2?
Yes.
Can't you find the intersections?
Yeah.
Booyah! That's y1, that's y2. You guys have this really cool intersect feature. Ooh, pre-cal graphing calculator handbook. Second trace. Number, something. It's not max, it's not min, it's the intersect, not 0. Is it number 4?
Either 4 or 5.
Oh, where are you?
Nice.
Okay, I'll have to come back to him. Use the intersect feature, that's my hint. Bummer. Yes, I'll have to find him. I think he's in my email.
Let's take a peek.
Intersect feature. Sean, when you did the intersect feature, what'd you get?
I got letter C, negative 0.391.
Make that one y2, make that one y1. There is one other option. The other option is you could, when you set these equal, you could subtract that guy to the other side. So now it's this minus that equals 0. And you could use the 0 feature instead. Intersect usually goes a little faster, but if the intersection's way up in the hundreds, thousands, 0 makes it nice and in your Zoom standard. Intersect or the 0 feature when you subtract, because you're setting these equal to each other. Number 79. Don't think we're getting into notes today, but that's okay. This is a good experience. Number 79. You guys want tonight to look over your practice exam one more time, right? The graphs of the derivatives, ooh, are shown above. Which of the functions have a relative max between A and B? Pause. These are first derivatives, right?
Yeah.
Don't even look at the graphs. First derivative test for relative extrema. What do you need? F prime to go from
Positive to negative.
Yeah.
at a critical number.
Oh,
The critical number is a 0 or dne of f. Question, which of these graphs goes from above to below at a 0 or dne?
the F.
Below to below, below to above to below. Ooh, below to above. The only graph that goes from above to below anywhere is F. Does that make sense?
Yeah.
Number 80, the first derivative is how many critical values? Critical values, another name for saying critical numbers. 0 to 10. Are they expecting you to do this by hand? Set this all equal to 0 or dne?
Just graph it.
Yikes, I'm try it. I can try though.
Okay, when you graph it, what are you going to make your x min? Zoom. You're going to change your zoom. What's your x min going to be? 0. What's your x max going to be?
10.
You're going to make your x min, x max of your zoom, of your window, 0 and 10. You're going to graph this in what mode? All of calculus in what mode? Radian. And you're looking for the zeros or the DNEs. And you're just counting them. You don't even have to find them. You're just counting how many times it hits the axis or has a vertical asymptote. How many times does it end up being? 3. Looking for zeros or DNEs.
I still have a question.
I just
77.
Yeah.
How does the intersection relate to them being?
Because the intersection is when they are the same, when the derivatives match, same slope as a tangent. Here's another real fast. Ah, we missed 2. Actually, number 84 can't do. That's a differential equation from second semester, well, this semester definitely.
How many can
Factor and simplify. You guys kill me. L'Hopital's. All you do is L'Hopital's. Derivative of A is a 0. So that's my hint. My hint is 0 over 0. L'Hopital's. All right, look at your practice test tonight. Ready tomorrow, ready to go. If you have any extra questions during lunch, I might have a meeting. You pop in practice. Michael gets 0 grade on Wednesday.
Oh no. Right.
That weird society?
Zach and Charlotte.
I did that at 3 a.m.
After school today.
This test out. Let's see.
是不是那啥都没写？我10点就开始写作业。打印的那个。
This D is like for the number
10点钟他们开始写作业，我说
you're gonna go above and
Hold on to practice test tomorrow.
放学的时候你
对啊，我也是放学时候。
Sorry, Tyler.
For like number 2, there was this like area that was above and under the x-axis. Do you